Hey guys, welcome back to Conditional Probability. I'm talking about question 8b, which some of you have had some difficulty with. I know this is a tricky concept, but keep being patient, keep trying, and it'll come together. So I have drawn a pretty complicated tree diagram here. Let me just explain it to you step by step. So remember, we've got two identical bags containing the same number of discs. Each of them contains 12 discs. And in bag A, 6 of the 12 were red, 6 of the 12 were blue. And in bag B, 8 of the 12 were red and 4 of the 12 were blue. So this first, and it's a 50-50 if you pick bag A or bag B. So the first part is, what if I pick bag A, that's a half chance, and I pick bag, and out of bag A I pick a red, that's half times half, which is a quarter, 3/12. Or if I randomly pick bag A and pick a blue, that's again half times half, which is 3/12 or 1/4. And if I do this with blue, bag B, red, chance is 8/12 because there are 12 beads and 8 of them are red. And so I get 4/12, 1/2 times 8/12 is going to be 4/12. And if I pick bag B, which is a half chance, and then pick a blue from that bag, it's half times 4/12, which is 2/12. I've left them all in 12ths. I think this will make life a little bit easier. Okay. At this point, you're probably wondering, what on earth is this next bit here? Well, the first bit up to these circled fractions, you can use that to answer question A, which is, what's the probability of selecting a disc that's red? So all you need to do for this first part is go, well, it's going to be 3/12, selecting a red, or the other way of selecting a red is here, 4/12, so altogether that's just going to be 7/12. Okay, so far so easy. The next bit is a little bit more tricky, so this is part B. This is where it gets tough. The disc selected is returned to the same bag along with another 2 of the same colour, and then you pick from that bag again. So let's just imagine a scenario. We picked A the first time, and out of that bag we picked a red. Now initially in the bag we said there were 6 reds, correct? According to the question. Now when we pick that red out, we put another 2 back with it. So instead of there being 6 reds, there's now going to be 8 reds, and not 12 beads, but 14, because there are originally 12 beads in this bag, but we've added an extra 2. So 8/14. I hope that's making sense. Pause and go back if you're not sure. And therefore, there must be 6/14 chance of blue, because we had 6 blues initially in bag A. But what happens if we pick bag A the first time, but instead of picking red, we pick blue? That's a 3/12 chance. Well, we picked the blue, so we must put that blue back in with an extra 2 blues. So instead of there just being 6 blues, there will be 8 blues and 14 counters. So 8 out of 14 will be blue, and 6 out of 14 will be red. So that's the top half. Now let's consider if we instead picked from bag B the first time and we got a red. We knew that 8 of those discs were red, and there were 12 of them. Well, if we pick a red from bag B, we're going to plop that back in with another 2 reds, which means instead of having 8 reds, we're going to have 10 reds, and altogether 14 discs. So a 10/14 chance of getting a red, thus a 4/14 of a blue. There were 4 blues initially in bag B. But what happens if we picked bag B the first time and then a blue? We put that blue back in and pop an extra 2 blues in. So instead of 4 blues, which is how many we have in bag B, now it's going to have 6 blues and a total of not 12 anymore, but 14 discs in the bag. So thus 8/14 chance of the red. The red number remains unchanged here. Okay, so I hope that makes sense. And now all you need to do is perhaps pause your video and fill in the rest of this chart here, which I'll just do now. 12/84, 9/84, 9 9/84, oh right, of course, 9/84, 12/84, and then 20/84, and 8/84, 8/84, and 6/84. I hope I've got that right. Maybe just check that. You can let me know if I've got it wrong. 12/84, 9/84, 9/84, 12/84, 20/84, 8/84. Yes, and it should all add up to 1. Okay, so now we've got our tree diagram all sorted. Let's see if we can answer the question. Okay, find the probability that it's the same colour as the first disc drawn. So, what's the probability that it's the same colour? So, if you look at all of the ones that are the same colour, we can tick them over here. Red, red, blue, blue, red, red, blue, sorry, that's bag B, whoops, blue, blue. Here we go. So, we're going to add them all up. We're going to go 12/84 plus another 12/84 plus 20/84 plus 6/84 equals 20, 30, 40, 44, I think. Is that 50/84? So that's the probability of them being the same colour. The last question is, what is the probability that bag A was used given the two discs are the same colour? So we're doing probability A given same colour. Okay, so that's our little formula again that we've been learning. And we know that that is equal to the probability of A intersection same colour all over the probability of same colour. So what is the probability of A intersection same colour? Well, A intersection same colour is where we are both A and same colour. So that is bag A, this one, same colour, and this one. That's A intersection same colour. So we're going to have 12/84 plus 12/84, which is 24/84, and we're going to divide that by probability of the same colour, which we did in the first question, which is 50/84. Now, when we're dividing two fractions and they've got the same denominator, they're going to cancel out like that, aren't they? So we're left with 24/50ths or 12/25ths. So that's how you do that one. I hope that makes sense to you. Let me know if you have any questions. Good luck.